Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.74. While solving this problem, we will be using current divider rule. Basic equations for the calculation of current I1 and I2 of this particular circuit using current divider rule is provided here. We also will be using Ohm's law. According to Ohm's law, voltage across any resistance R is always equal to the product of current through that resistance and the value of resistance itself. Parallel equivalent resistance calculation formula will also be utilized while solving this problem. R equivalent of two parallel connected resistances is calculated by taking the product of both resistances dividing by their sum. Now move towards the problem. Exercise problem number 2.74. Find voltage VAB in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find voltage between these 2 points labeled as VAB. So without wasting time, let's proceed towards the solution. In this network, the resistances values are given. If we know the value of current through these resistances, we can calculate voltage across these resistances, and later on we will be able to calculate voltage between these 2 points. Right now, no current is specified inside this network. So first of all, we will try to simplify this network and find current through these branches. We will start simplifying this network from this end and will find total supplied current through this voltage source. Later on, that supplied current will be used to calculate these branch currents. So start from here. These two resistances are connected in series connection, so their equivalent resistance can be calculated by adding both resistances together. 12 plus 8 will become 20 ohm. Modified circuit diagram is provided here. Now these two resistances are converted into parallel connection, so we will use this equation to calculate their equivalent resistance and replace that equivalent resistance with these two resistances. In this case, R1 will be 30 ohm and R2 will be 20 ohm. Place values inside the equation. Product of 30 and 20 divided by the sum of 30 and 20 ohm. Product of 30 and 20 will become 600 and sum of 30 and 20 will become 50. 600 divided by 50 will become 12 ohm. So we can replace these two resistances with a single resistance having the value of 12 ohm. Now these two resistances are converted into series connection. Find their equivalent resistance by adding the values of both resistances. 18 ohm plus 12 ohm will become 30 ohm. Modify the circuit. At this stage, these two resistances 30 ohm and 15 ohm are converted into parallel connection. We will find their equivalent resistance using this equation. In this case, R1 will be 15 ohm and R2 will be 30 ohm. Place values inside this equation. 15 multiplied by 30 divided by 15 plus 30. Product of 15 and 30 will become 450 and sum of 15 and 30 will become 45. 450 divided by 45 will become 10 ohm. So we will replace these two resistances with a single resistance having the value of 10 ohm. Modify the circuit. Now the circuit is simplified. We can calculate total supplied current using Ohm's law, dividing total supplied voltage with total resistance. Total current will be equal to 75 divided by 50. This 50 is the sum of all resistances because these are connected in series connection. So total supplied current will be equal to 1.5 ampere. We have calculated total supplied current. Now we will expand the circuit towards original circuit to calculate these branch currents. We will expand this 10 ohm resistance. It was the combination of 15 ohm and 30 ohm connected in parallel connection. So move a step backward. In this network, 1.5 ampere current is flowing through this voltage source and it is distributing among these two branches. So we will use current divider rule to calculate these branch currents, but before that we have to label these branch currents. This branch current will be labeled as I1 and this branch current will be labeled as I2. We are interested to calculate the value of current I1. The remaining current will flow from this branch. So we will use current divider rule equation to calculate the value of current I1. In this equation, R2 is the resistance of opposite branch. In our case, it is 30 ohm. R1 is the resistance of same branch. In our case, it is 15 ohm. And I into T is total supplied current. In this network, it is 1.5 ampere. Place values inside this equation to calculate the value of current I1. Current I1 will be equal to 30 multiplied by 1.5 ampere divided by 15 plus 30. Take the product of 30 and 1.5, it will become 45, and sum of 15 and 30 will become 45. 45 divided by 45 will become 1 ampere. So 1 ampere current is flowing from this branch. The remaining current, that is 0.5 ampere, will flow from this branch. Now we have to expand this 30 ohm resistance. It is the combination of this network. Move to previous step. In this network, the total supplied current is 1.5 ampere. From 1.5 ampere, 1 ampere is flowing from this branch. The remaining 0.5 ampere flowing from this remaining circuit. On this point again 1 ampere and 0.5 will merge and total supplied current will back towards the voltage source, that is 1.5 ampere. Now we have the value of current through this 18 ohm resistance. We are interested to calculate its voltage, but we don't have the value of current through this 8 ohm resistance. So we will try to find out this 8 ohm resistance current. For that purpose, we will again use this current divider rule equation to calculate the current of this branch. First we have to label these branch currents. This branch current will be labeled as I1 and this branch current will be labeled as I2. We are interested to calculate the value of current I1 only. For that purpose, we will consider this is our total supplied current because the sum of these two branch currents will be equal to 0.5 ampere. Current divider rule equation for this branch will be R2 divided by R1 plus R2 multiplied by I into T. I into T is total supplied current. In our case, it is 0.5 ampere. R2 is the resistance of opposite branch. In this case, it is 30 ohm. And R1 is the resistance of same branch. In our case, it is the sum of 12 and 8 ohm. Place values inside the equation. 30 multiplied by 0.5 divided by 20 plus 30. Here 20 is the sum of 12 ohm and 8 ohm. Solve this equation to calculate the value of current I1, that will become 0.3 ampere and the direction of current will be downward because it is entering on this node. Now we have calculated the value of current through this resistance as well as this resistance. So we can calculate voltage across these resistances. First of all, voltage across this 18 ohm resistance will be the product of current through it and the value of resistance. 0.5 ampere multiplied by 18, it will become 9 volt. Similarly, the current through this 8 ohm resistance is 0.3 ampere and value of resistance is 8 ohm. So voltage across this 8 ohm resistance will be the product of 0.3 and 8 ohm. It will become 2.4 volt. Now we will modify this original circuit by indicating voltage magnitude with their polarities. In this branch, the direction of current was downward, so current entering terminal is taken with positive sign and current leaving terminal is taken with negative sign. Similar case with this branch, the direction of current was right to left, so current entering terminal is taken with positive sign and current leaving terminal is taken with negative sign. And the polarity of this VAB is taken with this reference. VAB is indicating that point A will be on higher potential than point B. That's why point A is taken with positive sign and point B is taken with negative sign. Now we will calculate voltage VAB. For that purpose we will assume the direction of current this semi-closed loop in counterclockwise direction. We will start from here. Current entering terminal is positive, so 2.4 volt will be taken with positive sign. Next is 9 volt. Current entering terminal is positive, so 9 volt will be taken with positive sign. And next is voltage VAB. Current entering terminal is positive, so VAB will be taken with positive sign plus VAB equal to 0. Add these constants together. 9 and 2.4 will become 11.4. Place this 11.4 on the other end side of equal to calculate the value of VAB, that will become minus 11.4 volt. So the value of VAB inside this network is minus 11.4 volt. This was exercise problem number 2.74. Thank you. See you again in next video.